Alright, so let's begin with the maximum power transfer theorem. So please write along with me whatever I'm writing over here. So write down maximum power transfer theorem. Alright, and we'll solve two numericals from each theorem, that is superposition and maximum power theorem. Alright, now all of you are familiar with the Thevenin's theorem now by now? Yes or no?
Yes,
Hello?
sir.
Okay. So I'll just revise. So you have a complex circuit consisting of resistors, voltage sources, and current sources. So that complex circuit, you take the output terminals where you have the load resistor. Let's say this is RL, this is A and B. So this complex circuit, you replace it with a single voltage source called as Thevenin's voltage VTH and a single resistance RTH. All right. So here we have connecting A and B back and back with a load resistor RL. All right. So this complex circuit which we have drawn over here is replaced by this network, and this network is called as Thevenin's equivalent circuit. Thevenin's equivalent circuit. So this is what is and you know how to calculate VTH. We first calculate VTH, right? How do we calculate VTH? We open circuit, you remove RL and you calculate open circuit voltage between A and B. Then you calculate RTH. It's a Thevenin's resistance. How do you calculate RTH? We deactivate all the sources in the complex circuit. We remove RL and measure the resistance between terminals A and B. Alright, yesterday we have discussed that. Now, what is maximum power transfer theorem? So, write one statement over here. Your maximum power will be transferred from the source to the load when RL is equal to RTH. Okay, so this is the maximum power concept. So what is the source over here? This is my source, right? This yellow color is my source, and this green color is my load. So maximum power will be transferred from the source to the load whenever we say that RL is equal to RTH. That is what is mean by maximum power transfer theorem. You got it? Yeah?
Yes, sir.
Okay. Now, so maximum power will be transferred from the source to the load when RL is equal to RTH. And what will be the maximum power? The maximum power will be P max, which will be given by VTH square upon 4 RTH. Now there is a derivation for this. We will discuss in in a second. So please write down these things. So it's an extension of Thevenin's theorem. Okay, just that your maximum power will be transferred from the source to the load whenever your source resistance RTH is equal to load resistance RL, and that maximum power will be VTH square upon 4 RTH. Okay, now in my class I have already said this entire statement. Okay, yeah, so this is the same thing which we have written. This is the proof of it. So in the circuit, what is IL? Can you tell me what is IL? IL will be VTH upon RTH plus RL, correct? Current is voltage upon resistance, yes or no?
Yes, sir.
And power across RL will be given by I square RL. Okay, IL square RL. So IL square is VTH square upon RTH plus RL square, right? So that is what we have considered into RL. Now, you know what is differentiation of derivative? U by V, right? So
Yes, sir.
we'll be using that in equation number 1. So numerator term we call it U, denominator term we call it V. In this expression, RTH and VTH are constants, right? And so your power across the load RL depends upon only on RL. So RL is the variable. So to find the maximum power, you need not write this. Just listen. You can refer the derivation later. To find the maximum power, P max will differentiate equation number one with respect to RL. Okay, and set the result equal to 0. Okay, so if you want to find the maximum quantity, you differentiate it and set it equal to 0. So when we differentiate it, we know the d by dx u by v rule, right? V du by dx minus u dv by dx upon v square. And in our case, u is vth square rl and v is rl plus rth the whole square. So we substitute it accordingly, and we treat it equal to 0. So when we treat it equal to 0, the denominator terms will go, only the numerator term will remain. So these are the numerator terms. Okay, you can check it out. Now here we rearrange things and keep vth square into rl plus rth common. So this thing will go. So we are left out with rth plus rl minus 2rl equal to 0. So if we work it out further, rth comes out to be equal to rl. So this proves the maximum power transfer theorem statement. Got it? You need to work it out on your own. You need to solve this on your own and get this result. Any doubts up till now?
No, sir.
All right. Now, from 1, this is the power expression Vth square RL upon Rth plus RL the whole square. Now, in this we substitute RL equal to Rth. So we can write power is equal to Pmax, and Pmax will be Vth square into Rth upon twice Rth square. So if you work it out further, you will get this expression. Pmax is Vth square upon 4 Rth. Alright, and that is what we have written over here. So this is the theory behind the maximum power transfer theorem. They can ask you in the exam that explain maximum power transfer theorem and prove that Pmax is equal to Vth square upon 4 Rth. Alright, so you need to explain all the steps, what I have did in the last 2 minutes. Okay, got it? So can we start with the numerical? Everyone?
Yes, sir.
Any doubts, anyone? No? So are you all ready with your calculators and your notebooks? So can we start now? Okay. So let's begin with numerical number 1. So write down along with me. Numerical number 1. Write down, find the value of RL and Pmax for circuit below. So please draw the circuit. So it's an extension of Thevenin's theorem only. So all the steps will be same. At the last step it will differ. So please draw it along with me. And here is my load RL. These values are 5 ohm. This is 10 volt, 6 ampere, 2, 3 ohm, 3 ohm, 4 ohm, and this is RL. So whenever there is RL, we mark these points as A and B. Completed this? Okay, complete it please. I'll wait for 10 seconds more. So I'll write the solution in blue color. Can I start? Hello.
Yes, sir. Yes, sir.
Okay. So the clue is first we find RTH. Then second step we'll find, then we will treat that, then we say that maximum power will be transferred from the source to the load whenever RL is equal to RTH. Then we'll find the value of RL. Third thing is we'll find the value of VTH. And fourth, once we get RTH and VTH, we'll find Pmax, where Pmax is VTH square upon 4 RTH. So this is the flow we'll follow, 1, 2, 3, 4. So let's begin with finding RTH. Now tell me what we do to find RTH. What is the procedure? Come on. Hello. Yesterday you were
We
there
remove
now?
RL.
Yeah,
Yes, sir.
correct.
We remove
Absolutely
RL.
correct. Remove RL and then we deactivate all sources, right?
Deactivate all the sources. Yes.
Yeah, deactivate all sources. So I'll draw the circuit diagram here only. So you have resistance. Resistance will remain as it is. Voltage source will become short circuit. Then current source will become open circuit. Then we have 2 ohm over here, 3 ohm and 4 ohm. And this is A and B. Okay, this is 3 ohm, this is 4 ohm, and we need to find RAB, resistance between terminals A and B. Alright, now tell me, I hope you are writing also along with me.
Yes,
Now,
sir.
in this circuit, uh, is anything parallel? Is my 5 ohm and 2 ohm in parallel? Yes, no?
Yes.
Yes. So 5 ohm parallel to 2 ohm. I hope you know how to do it. 5 into 2 divided by 5 plus 2. That is coming out to be 1.428. Please check.
Yes, sir. It is 1.48.
Okay, now this I will draw over here and the remaining two resistance. So this is my A and B. This is 3. This is 4 ohm. This is 1.428 ohm. Now, how to calculate RAB? Tell me, what is RAB?
Equivalent resistance of those
No,
three.
what it is? What is it from this circuit? With can you see? Are all the three resistors in series or parallel?
3 and 4 are in parallel.
No, how it is in parallel?
It's an 8
For
point.
for
It's in
something to be in parallel, they both the terminals should be connected together. This is in parallel. This is in series.
Yes, yes. Got it.
This is in series. This is parallel. Okay. So
Yes.
this is something
Agree.
extra. So all three are in series. So RAB is 3 ohm.
8.428.
Yeah. So we write it like this. And then we write RAB is equal to RTH is equal to 8.428 ohms. That's the value of RTH. Got it? So please
Yes,
complete
sir.
up till here. Complete up till here. I'll wait for half a minute. Okay? Completed? Then we'll write a statement that maximum power is transferred from source to load when RL is equal to RTH, and that is equal to 8.428 ohms. Alright, so in a numerical we were supposed to find RL, so this is the value of RL. Are you all following? Everyone? I can see only one person saying, so other persons can speak up also. You have any
Yes,
doubt?
sir.
Do you
No,
have
sir.
any doubt?
No, sir.
Alright, okay. Then as per the sequence, once we found out the value of RTH and we have found out the value of RL, next is we'll go for VTH. So write down second. If I'm little fast, please stop me. Tell me, I'll go a little slow. If I don't get any feedback, that means I'm going at a good speed. Alright. Next case, how do we find VTH? We'll remove RL and calculate VAB. or VTH. Okay, so I'm redrawing the same circuit. I'm redrawing the same circuit, but removing RL. So you can also do the same. Quickly redraw the circuit. There are two resistors over here, and this is point A and B. This is 5 ohm, 10 volt, 6 ampere. This is 2 ohm, 3 ohm, and 4 ohm. So here we need to find VAB or VTH, or it is also called as open circuit voltage. All right, drawn till now. Yeah.
Yes, sir.
Now, can you tell me from here how do we calculate VTH? So always we go from B and then we'll go to A like this. So can you tell me from here? Let's say inside we apply mesh analysis, and these are the two loop currents I1 and I2. Let's say. Now can you all tell me what is VAB? How to calculate VAB? It's open circuit voltage, right? So do any current flow from 4 ohm and 3 ohm resistance? No, na. It's open circuit. It's zero. So no current flows from 4 ohm and 3 ohm resistance, and we are going from B to A. And here we have marked the current as I2. So we are going against the current. So it will be 2 ohm into current flowing through 2 ohm, that is I2. Do you got it? Yeah. So VAB is 2 ohm into I2. Did you all get it? Why it is minus? Why it is not minus? Because if it for it to be minus, the direction of I2 should have been negative. It should have been opposite. And we are going from B to A. And why we have not considered 3 ohm and 4 ohm? Because it's open circuit. So current flowing to 3 ohm and 4 ohm is 0. Did you all get this? How we have written this formula?
Yes, sir.
And we need to calculate I2. Now tell me, can we apply, is this a normal mesh or a super mesh?
Super mesh.
Yeah, exactly. So if this is a super mesh, let me mark the super mesh. So this blue color one is my super mesh. And what is the super mesh equation? I2 minus I1 is equal to 6, right? Why not I1 minus I2? Because I2 is in the same direction of 6 amperes. So this is equation number 1. Got it?
Yes, sir.
Now KVL to super mesh. So we need to follow this blue part. So here we go plus minus plus. So we write 10 minus 5 times I1. Then we don't go over here. Then we'll go over here. Here we have minus 2 I2 is equal to 0. That's it. Then we arrange these terms. Minus 5 I1 minus 2 I2 is equal to minus 10. So we have two equations, two unknown. We can solve it easily. So I write it in a matrix form. I1 I2, and here I write it as, see, very carefully, I1 is the first coefficient, so minus 1 1 6, and here we have minus 5 minus 2 minus 10. Did you all get it, how we wrote this matrix? Now next thing is solve this in your calculators and get me the value of I1 and I2. I'll wait for your answers. I1 and I2 both will be in amperes. Unit is amperes. So I'll give you all some time. Let me know the value of I1 and I2. Solve using your calculator. Put the coefficients and let me know the value of I1 and I2. Anyone, what's the answer? Anyone has got the answer?
I1 is minus 2 by 7 amperes
Um,
and
2 by 7 and here.
I2 is 40 by 7.
40 by 7. All right. So now, once we got I1 and I2, next we'll calculate VAB. So VAB is I2 times 2, 2 amperes. So what is this thing? 40 by 7. Okay. 40 by 7 into 2. So how much is that in fraction? So basically we are getting 80 by 7. So how much is 80 by 7? Can you all let me know? 80 by 7?
11.428.
Yes. That's the value of VTH. This is VAB, nothing but VTH. Yeah. Please complete till here. Are you all ready now with the third part? Everyone ready? Can I proceed forward?
Yes, sir.
So next third part, may we draw the Thevenin's equivalent circuit. Thevenin's equivalent circuit. So let's draw it quickly. So this is my VTH. This is RTH. And this is load RL. Okay. So this is point A, point B. All right. And how much was RTH? I think 8.43, right? RL is also 8.43. Just check. 8.428, right? I guess.
Yes, sir.
8.432.
Yeah, yeah, fine. That is fine. 8.428 or 426, it's fine. Now you calculate P max. What is P max? VTH square upon 4 RTH. So calculate this P max. It will be 11.428 divided by 8.428. No, 4 times. Okay, 4 times RTH, and this is square. So please calculate the value of P max and let me know how much it is. 11.428 square divided by 4 times 8.428. What is this answer?
3.873. 3.874.
3.87.
4.
Okay. Everyone got this answer? Yes or no?
Yes.
Others, you all did get got the answer? Similar?
Yes, sir.
All right. Now, what we will do is we'll simulate the circuit in LTspice and check the values if they are coming same or no. All right. It will be a practice for you all also. You all will get one assignment where you have to solve it using LTspice. So let's build the circuit. Actually, I didn't share the link of the LTspice download, right? I forgot it. I'll share it by today. You can watch the recording later and do the similar steps. Let me minimize it. LTspice is a tool wherein you can verify all the answers even without solving any numerical. So I've opened a new schematic and I'll add registers in it. Okay, I minimize this. Then I'll add a register over here also. And I have two registers. So I'll control R. To rotate the register, I'll press control R. So I've taken a register, control R, and here also I have pasted it. Alright, now I require a voltage source. So I type voltage and I require one current source. So here I'll type current. I need to rotate it. So control R. Okay, let me use it again. I'll press Ctrl R. I'll select this. Yeah, and now I'll join everything together with the wire. If I want to move a register, I can move it like this down. Yeah, now connect the circuit back with wires. Okay, I have to move a little down. So we are going to check everything in simulation, cross verify our answers, and check whether we are getting maximum power being transferred properly or no. Alright, these are points A and B. So first we will check VAB, okay? We'll calculate VAB. This is point A and this is point B. Let me call it B. Okay, so we'll calculate VAB. Now let me add the values. So here it is 5 ohm. This is 10 volt. This is 6 ampere. This will be 2 ohm. This is 3 ohm. And this is 4 ohm. So what we do in calculating VTH, we remove RL. We remove RL and directly calculate VAB. Alright. And I have to connect a ground over here also with a wire, because circuit without the ground will not be simulated. Now I'll simulate it and I calculate VAB. So I'll run and I'll go to DC operating point, click on OK. So it will give me the value. Now VAB, see B is 0 VA. So how much is that? How much did we get? 11.428, right? See this. See VAB is VA minus VB. See this. Are you getting the same? Yes.
Yes.
So this is the way we can verify in simulation. So our VAB is, let me write it down. Uh, this is what we got, right? So I'll right click, add a comment, go to draft, comment, and added these points. So this is VAB, 11.426. Now next is we calculate our RTH, right? So for RTH, what did we do? We open circuit A and B and we deactivate all sources, right? Now how do we deactivate the sources? We open circuit it and we short circuit voltage source, open circuit current source, and short circuit this thing. All right, understood. Now actually we have to connect something to the output. Now how do we calculate RAB? Now there is no ohm meter or a resistance meter in LTspice. So what do? We apply a test source, 1 volt test source at the output terminals A and B. And how do we find the current? So current will be this voltage 1 volt, which we are giving over here now, divided by the current flowing through this voltage source. Okay, and that will give us the value of RTH. So let me simulate and show it to you. So I'll simulate, run. So what is the current flowing through the current source? Don't worry about the negative sign, because in LTspice the current flowing out of the voltage source, that is out from the positive terminal, is considered as negative. So ignore the negative sign. Can someone do 1 divided by 0.1186? Can you do 1 divided by 0.1186? How much is that?
8.431.
Okay, so I'll write RTH will be, or RAB will be, V1 divided by current flowing through V1, and we consider that positive. So 1 divided by 0.118644. How much is that? What did you tell? 8.4.
No, sir. If we divide it by 0.11864, then the value will be 8.428.
To 8.428 ohms. And is this the value we got over here? Yes. See,
Yes, sir.
8.428. Correct. So RTH also we got it perfectly fine. Now we'll draw the Thevenin's equivalent circuit and see whether the power max is this or no. All right. So I'll minimize this. I'll draw the Thevenin's equivalent circuit. So for that I'll require a voltage source. over here. Then I require a resistor. Even if you don't have that software right now, you can watch the recording. Yesterday's and today's recording, I'll share it with you all. So it will be helpful. Any numerical in DC circuits in module number 1, you can do it, then do it with this software in minutes, and you will get the answer. I'll add the ground. Okay. Now let me concentrate on this part and let me maximize this. Alright. So over here, what is my voltage source? This is VTH, right? Let me call it VTH. This is RTH. And this is RL. Okay. Now current over your voltage is 11.428. Resistance is 8.428. And what is RL? 8.428. Alright. Now I want to calculate power max, right? So I'll again simulate. Here we don't get the power, here we get the power. Okay. Can you see when I bring the cursor, bring my pointer, this plus sign near RL, below you see below. Here you will see power dissipation. Did you saw? Right at the below, bottom terminal. Did you get that? Did you
Yes,
see
sir.
power dissipation? What is it? 3.87. Can you read out?
3.873967.
So that is similar to 3.874, right? So this is the way we can calculate power max, everything using this software. Got it? So you can try it out on your own self later. Try it out in your own laptops or desktops and verify this, maximum power transfer theorem. Actually, any theorem you can verify. Even mesh and nodal analysis, everything, super mesh, super node, everything you can verify it using this software. So this software is very handy. All right, everyone clear? So our simulation software is also giving us similar answers. Any doubts so far before I proceed? No? Can we start now with this numerical number 2? Everyone?
Yes.
Okay. So try to do this on your own in numerical number 2. Just give me a minute. I'll adjust the setting. Okay. So let's go. Numerical number 2 for maximum power transfer theorem. So write down numerical number 2. Find RL and determine maximum power delivered to the load. Okay, that's the question. And this is the circuit diagram. Please draw it along with me. Okay. Now see, RL is not always at the extreme left hand side. It can be anywhere. Now this circuit is a classic example of that. Let me show you. This is 25 amperes. This is 5 ohm, 10 ohm, 10 ampere. This is RL. So RL can be connected anywhere. This is 30 volt. All right. Now whenever there is RL, we mark that as A and B, right? A and B. All right. So I'll give you 10-15 seconds more to note down the diagram, and we'll start solving over here. The solution pattern will be, first we'll calculate RTH, then we calculate RL, then we calculate VTH, then we calculate maximum power delivered to the load. So can we begin? Have you noted the diagram, everyone?
Done, sir. Yes.
Okay. Now first we'll find RTH. So always it's a good habit to write down what we'll do to find RTH. RTH, we will remove RL, and second thing is deactivate all sources. So how many sources are there? 1, 2 and 3. All right. So let's draw it together. So what happens to current source when we deactivate it? Open circuit, right? So this is open circuited. Then we draw 5 ohm resistance, then 10 ohm, then again 10 ampere current source is open circuit. So this is open circuit. Then A and B point are also open circuited. We remove RL, right? This is point A and B. Then we have 2 ohm, then 10 volt, 10 ohm, and then this is short circuit. Got it? This is 2 ohm, 10 ohm, and 10 ohm. Have you drawn the diagram? Hello.
So 1 minute.
Okay. So to find RTH, we remove RL and we deactivate all the sources. When you are done, please let me know.
Yes, sir, done.
Okay. Now, tell me what happens to this 10 ohm resistance. It's parallel to a short. So what happens to it? Yeah, tell me what happens to this 10 ohm voltage source or 10 ohm resistance when it is parallel to a short. So it will be replaced by a short circuit only. Okay. So I'll anything in parallel to a short will be short circuit only. So this is point A and B, and here we have 2 ohm resistance, and this is short circuit only. All right. Now tell me, did you get it? How why we have done this? Because anything parallel to a short, so this is a short parallel to around 10 ohm resistance. Understood this?
Yes, sir.
And now which resistors are in parallel or which are in series? Can you tell me which are in series? So this 10 ohm and 5 ohm are in series. Okay. So we write 10 plus 5. So now we have A, here we have B. So on one side we have 15 ohms and on other side we have 2 ohms. You all got it? So what is RAB now? 15 ohms parallel to 2 ohms. Did you all understand? Any doubts in this? So please calculate and let me know. It will be 15 into 2 divided by 15 plus 2. How much is this? How much is this number? 30 divided by 17. Hello. Anyone can tell me this number? What is RAB and RTH?
30 by 17, which is 1.64. 1.764.
Yeah, that's correct. 1.764 is the answer. Everyone has got it? Others?
Yes.
So write a statement over here for maximum power to be transferred from source to load. What do we say? RL should be equal to RTH, which is equal to 1.764 ohm. It's mandatory to write this statement, without which, if you write directly RL equal to RTH, you will lose 1 mark. So you have to write the reason why. For maximum power to be transferred from the source to load, RL should be equal to RTH. Alright, ready to move to the next step now? Everyone completed up till here?
Done, sir.
Okay. Next is find VTH. So for finding VTH, we do two things. First is remove RL. Next is calculate VAB, which is equal to VTH. So let's draw the circuit again. So I'm drawing the circuit again without RL. Okay. So I have you can check it out. This is 25 amperes current source. Parallel I have a resistor 5 ohm. Then this is 10 ohm. Then I have a current source of 10 ampere. Then I have point A and terminals A and B. Then 2 ohm. Just cross check the values from the main numerical. Are these the values? And this is 30 volt. This is 2 ohm. Just confirm is just the circuit. All the values are fine. Main circuit is matches with the main circuit. I've just removed RL. That's it. Correct?
Correct, sir.
Okay. Now, even without doing anything, tell me how do we calculate VAB? Listen carefully. Huh? We'll always start with B and go from here till here. Now tell me what is VAB. Let's say we apply over here mesh analysis and this is, let's say, I2. Now can you tell me what is VAB? I'm going from here. This is minus, this is plus. Can you tell me VAB? Come on. When you go from here, yeah, it is a rise in potential. So it is 30 and then 30 plus or minus. Whether plus will come or minus will come. I2 into 2 ohm. It will be plus because we are going from B to A and the current is opposite. When the current is opposite, we treat it as positive. When the current is in the same direction, we treat it as negative. So in the back of our minds, VAB is this formula. I mean this expression. And for that, we need to find I2. What is I2? Understood this? How we find VAB? Everyone?
Yes, sir.
Alright. Now, next immediate thing we can do is, there are 3 loops now. It doesn't make any sense. So, do you know source transformation? Hello? Source transformation is what? A current source in parallel with a resistance can be converted into, this can be converted, let me show you over here. A current source with a parallel resistance can be converted into a voltage source with a series resistance. Okay, and let's say this is 25 ampere, this is 5 ohm. What it get converted into? How do we calculate the voltage? So voltage will be current into resistance. So this is 25 into 5, that will be 125 volt, and the resistance value will be same. This is something called as source transformation. Understood? Yeah. Hello.
Yes, sir.
Got it.
Okay, now we calculate it from here, the things. Okay, I redraw this circuit again. So this will be 125 volt. This will be a voltage source. Okay, let me join them together. This will be 30 volt. Okay, just a minute. Okay, my document is stuck. You can note it down till then. I hope you are following all the things. Whatever we are doing, we are understanding. And if you, in case if you have any doubt, let me know immediately. Okay, don't wait for numerical to be completed. You can ask your doubt immediately. If anything is not clear, yeah, tell me. This is 30 volt. This is 10 ohm, 2 ohm. This is 5 ohm, and this is 10 ohm. Now we are having how many loops? 3 loops. So this is I1, this is I2, and let's call this as I3. Okay, how much is this current source value? 10 ampere. So that's how we convert this circuit. We have just made one change. Instead of drawing this current source with a parallel resistance, we replace it with a voltage source with a series resistance, so that we can easily apply mesh analysis. Clear it is, everyone? Please let me know.
Sir, so we can use series connection and add 5 and 10 ohm. We can do that.
We can add, yeah, we can add this too, but I've written it like this only. Let it be, na, while writing the equations is one and the same thing only, right? You are
Yes.
saying instead of 5 and 10, can I write 15? Yes, why not? That is your question, right?
Yeah, yeah.
No problem, we'll write it as it is. Some people then draw another diagram, but still, if we can write 15, that is fine. Now, can we apply mesh analysis in loop 1 and 2 or mesh 1 and 2? No, na? Why? What is the problem? This current source. So what is this numerical? What is this? Let's do super mesh. Okay. So mesh number 1 and 2 forms a super mesh. So what is the equation of the super mesh? I2 minus I1 is 10
10.
ampere. So this we call it equation number 1. Okay. And what is the super mesh? What is the super mesh form? By this loop. Yes, super mesh hai. So I need to apply KVL to the super mesh. Okay. So let's apply KVL to the super mesh. Okay, now let me know. Only follow the red color box. Okay. Now here, let me know. 125, right? 125 minus 5i1 minus 10i1, then minus 2i2, then minus what will come over here? Minus 10. Let me know. Minus 10. 10 ohm is set between loop 2 and loop 3. So what will come over here?
I1 minus I2.
अरे I1 कैसे ना? This is I2 and I3 ना? So this is I2 minus I3. 10 I2 minus I3. This is simple mesh
Oh,
analysis.
got it.
I1 कहाँ से आ गया? I1 तो है ही नहीं ना यहाँ पे. Set between loop 2 and 3. Now we solve this systematically. So here we'll get minus 15 I1 minus 12 I2 plus 10 I3 is equal to minus 125. This is equation number 2. All are getting this? Did you get these answers? This equation, similar equations.
Yes.
Now, we have three unknowns, I1, I2 and I3. And we have two equations. So we require one more equation. Can I apply KVL to this loop, the third loop, in the loop 3? Loop 3 we can easily apply, na? No problem in that, right? So we'll apply KVL to loop 3. So when we apply KVL to loop 3, what is the equation we write over there? Yeah? Come on, let me know, or else there is no point of keeping these lectures if you all don't speak. Let me know this loop. What equation do we write?
30 minus 10, no, 10 into I3 minus I2.
No, minus 10 into I3 minus I2, and then we have plus to minus. We are going from positive to negative, so it will be minus 30 equal to 0.
Minus
This,
30 equal to 0.
yeah, that is the equation. So this will be 10 I2 minus 10 I3 is equal to 30. This is equation number 3. So please write it up till here. So please complete up till here. Have you all completed? Yes. Now use your calculator. You can use your calculators and solve it simultaneously. So first I'll write it in the equation form. These three equations from 1, 2 and 3. So I'll write over here. From 1, 2 and 3 we get coefficients you should write. So I1 coefficient first, then I2, then I3. So I1 is minus 1, 1, 0, 10. For equation number 2 it is minus 15, minus 12, 10, minus 125. For third one I1 is absent, so it is 0. This is 10, minus 10, 30. Did you all understand how do we write this? How did we write this? Yes or no?
Yes, sir.
Now solve this simultaneously. Put this coefficients in your calculator and let me know I1, I2, I3. I'll wait for your answers.
So I got I1 as minus 65 by 37.
No,
No.
that's not correct. So see whether you have put all the positive and negative signs properly. The I1 which you told is not correct. So what's the correct one? Everyone please contribute and let me know I1, I2, I3 value.
Is it 75 by 17?
Yes, yes. 75 by 17. Then I2 is?
245 by 17.
Yeah. What mistake did you do?
So I wrote uh, I wrote it as minus 10 in the second column.
So see, one mistake, one plus or minus mistake will ruin your answer. It will give you wrong answers. So be very careful. Everyone, anyone else got these answers?
Yes, sir.
All right. Now what to do with this? You have to put it in VAB. VAB is 30 plus I2 times 2 ohms. So VAB is 30 plus I2 into 2 ohms. So let's substitute the values over here. VAB is 30 plus I2 is 245 by 17 into 2. So let me know the value of VAB. Is it 58.82? Just cross check. Is it coming same? Hello. Anyone got VAB as 58.82?
Yes, sir.
Okay, and that is equal to VTH. So now only thing left is to calculate Pmax. So Pmax is, you can draw a Thevenin's equivalent circuit, that is fine. But in order to save time, I'm writing VTH square upon 4 RTH. So VTH is 58.82 square divided by 4 into what? How much was RTH? RTH was 1 point,
1.765.
yeah, 1.764765. So let me know Pmax now. 58.82 square divided by 4 into 1.764 765. Use your calculators and let me know the value of Pmax. 4 9.
490.333.
I am getting 490.3.
Yes.
Yeah, close to this will be correct. Everyone getting 490 watts?
Yes, sir.
Okay. Yeah. So with this we conclude maximum power transfer theorem. And now we go to superposition theorem. We'll go to superposition theorem. Everyone ready? Hello.
Yes, sir.
So actually instead of explaining you superposition theorem, let's apply superposition theorem and then you will understand it better. Okay, instead of explaining you the statement and superposition theorem, so write down the numerical, then I'll come to the statement, don't worry. Write down numerical number 3 for the day. First let me explain you with an example. So write down, find, give me a minute, I of 2 ohm using superposition theorem. Okay, wait a second, my tab is little bit misbehaving. So you write find I of 2 ohm using superposition theorem. Let me close this document and open again. Yeah, so write down find I of 2 ohm using superposition theorem and draw the circuit please. This is 10 volt, 2 ohm, 10 ohm, 5 ohm, and this is 40 volt. Okay, again it is starting to give trouble. This is 40 volt and this is 10 volt. Yeah, we need to find I of 2 ohm. So I of 2 ohm, I can mark it over here. I of 2 ohm. This is 20 volt. Everyone has drawn the circuit? Hello?
Yes.
Okay, now listen carefully. So superposition theorem is applicable whenever there are more than one sources in the circuit, whether it is a current source or the voltage source. So we need to solve. I mean, this is very easy. Superposition theorem is very easy, but it's lengthy, slightly lengthy. You'll understand when we'll solve this numerical. So in this, there are three sources, right? There is a 40-volt voltage source, then there is a 20-volt voltage source and 10-volt voltage source. So what we do is there are three cases. Case number one, case number two, case number three. We consider 40-volt voltage source alone. So what happens to 20 volt and 10 volt? Then deactivate them. So consider 40 volt alone and find I2 of ohm. Let's call this I2 dash. Okay. Then we'll go to 20 volt voltage source alone. So when we do that, 40 volt and 10 volt will be short circuited and we find I2 double dash. Then we'll go to 10 volt voltage source alone. That means short circuit 20 volt and 40 volt and we'll find I triple dash. I2 triple dash. Okay. So we got the current for individual voltage sources. Now as per superposition theorem, we'll say is the addition of all the currents whenever sources were active one at a time. Yeah, that is superposition theorem. Did you get it? At the end, we'll add all three together and we call this is the current flowing through 2 ohm resistance. Are you following what I did just what we did just here? Hello,
So could you explain again? I didn't get it.
you didn't understand.
No, sir.
There are three sources 40 volt, 20 volt, and 10 volt. So, first you consider one source at a time. When you consider 40 volt voltage source, 20 volt and 10 volt will be short circuited, deactivated. Then you find the current flowing through 2 ohm resistance. We call it as I2 dash. Okay. Then we'll go to 20 volt voltage source. We deactivate 40 and 10. Okay. And again find the current that we call it I2 double dash. Then we go to 10 volt voltage source. So while doing that, 20 volt and 40 volt will be short circuited, deactivated. And at a time only one source is active. And we find the current, we call it I3 dash. And we add them together and we say according to the superposition theorem, I2 ohm is I2 dash plus I2 double dash plus I2 triple dash. That is what the superposition theorem is. Understood now? Let's solve
Yes.
this numerical and then we will understand. It's very easy, but it's lengthy. So let's start. So solution. We'll consider the first case. Let me use green color. Consider, write down, consider 40 volt voltage source alone. So when you consider 40 volt voltage source alone, how will my circuit will be? Like this. Others will be short circuited. Only one source will be active at a time. So this is 40, this is 5, this is 10 and this is 2. Did you all get it? And this current flowing over here will be I2 dash. This current will be I2 dash. Understood or no? Hello.
Yes, sir.
And now we can easily apply. I mean, now what students do mistake is they see this 10 ohm and 2 ohm are in parallel and they convert it. No, you cannot convert it because you need to find the current through this 2 ohm. So 2 ohm will remain as it is. So which analysis will we apply? Mesh analysis, right? I1 and I2. Yes or no? You can easily
Yes.
write now mesh analysis. So let's write it further. KVL to loop 1 means here. So what you will write? 40 minus 5i1 minus 10 i1 minus i2 is equal to 0. Got it? Did you understand how do we write this?
Yes.
So now you rearrange the terms. So you will get minus 15 I1 plus 10 I2 is equal to 40. We got equation number 1. Then we'll go to KVL to loop 2. This you have to do it quickly. So then minus 10 I2 minus I1 minus 2 I2 is equal to 0. Basically over here we know I2 will be equal to I2 dash. Okay. Then rearrange this. This will be 10 I1 minus 12 I2 is equal to 0. So quickly solve them together. Solve them using simultaneous equations. So here you will have minus 15, 10. This is I1, I2. This is 40, 10. Coefficient of I1 and I2 and 0. Now solve this and let me know what is I1 and I2. Are you following?
Yes.
So quickly tell me what is I1 and I2. Anyone with the value I1 and I2?
I1 is 40 by 3.
No. Okay. Here it is. See, listen. We did one mistake. See, in a hurry. See here. This is minus 15. This should be minus 40. So this is what happens when we do it in a hurry. So check your, don't just copy these things. You need to check it out. So this will be minus 40. Now tell I1 and I2. Tell me I1 and I2 now. It will be 6 and 5. Anyone got 6 and 5? Remaining people, please help it out. I'm asking every one of you. Is it 6 and 5?
Yes, sir.
So I2 dash will be equal to I2 will be equal to 5 amperes. And the direction is this word. So this one answer we got. Got it? Understanding?
Yes.
Now we go for the second part. So please be ready. I'm waiting for you to note down. If you have noted down, then well and good. Then we'll go to the next second case. Okay. So first we have considered 40-volt voltage source. Now we'll consider 20-volt voltage source. When we consider 20-volt voltage source, 40-volt and 10-volt will be short circuited. So let's do it. So please help me out over here. Second case, consider 20-volt source alone. So I'm drawing the circuit with only 20-volt source. Remaining things are short circuited, the voltage sources. So you can check the main circuit. This and this will be short circuited because there was a voltage source. That's it. This is 2 ohm, 10 ohm, 5 ohm. This is 20. Did you all got it? How we get this equation? How we got this diagram circuit? Only one source will be active. And now the current flowing through 2 ohm resistance will be I2 ohm double dash. How do we solve this? How do we solve this equation? How do we find I2 dash?
In mesh analysis.
Again mesh analysis. Call it I3 and I4 this time. Okay, now write down KVL to loop number 1. So we get minus 5 I1. This is plus minus, so it will be minus 20 minus 10 times I3 minus I4 is equal to 0. Remember, I4 is I2 double dash.
So
Okay.
minus 5 I3 I1.
Yeah, correct. Minus 5 I3. So it will be minus 15 I3 plus 10 I4 is equal to 20. Let's call this equation number 3. Okay. Now we apply KVL to the loop 2. KVL to loop 2 will be minus 10 I4 minus I3 minus 2 I4 is equal to 0. So what it will be? 10 I3 minus 12 I4 is equal to 0. Now we put it in the matrix form. It will be minus 15, 10. This is I1 and I2, and here are the right hand side. 10 minus 12, 0. So solve this and let me know the value of I1 and I3 and I4. So I'll wait for your answers. You have to tell me the value of I3 and I4.
So I3 is minus 3.
Yes. And I4?
Minus 5 beta. Minus 2.5.
Yeah, that's correct. I told you it's easy, but it's lengthy. So I4, I2 double dash is minus 2.4. Direction is this way. So we got this answer also. Everyone has reached up till here? Hello?
Yes, sir.
Okay. Now we go to the third one, next one. Uh, Point number 3. Consider what is left? 10 volt voltage source, right? 10 volt
Yeah.
source alone. So we'll go about to the main numerical. So when we consider 10 volt voltage source, 20 volt and 40 volt will be short circuited. Huh? Just remember. So we'll do that exactly. So here it is 5 ohm resistance. Here there is a voltage source will be short circuited. Here again there is a voltage source short circuited. Then we have 10 ohm. This is 10 volt and this is 2 ohm. Okay. And now the current flowing through I2 ohm will be I2 ohm triple dash. Okay. Fine everyone. Now how do you solve this further?
Same mesh analysis.
Not needed. This time it's not needed. You know why? Earlier we cannot manipulate 2 ohm resistance. It is fine, right? But now can we say 5 ohm and 10 ohm are in parallel? Yes or no? Because we need
Oh,
not
yes.
find the current here. So be smart and call it as 5 ohm parallel to 10 ohm. The answer will be 3.33 ohm. And now I'll redraw the circuit. I know you can solve it using mesh and the answer will come correct also. But it will take extra time. It will take extra time. this is minus, this is plus, this is 10 volt, this is 2 ohm. Now can you find the current? Yes, I 2 ohm triple dash. You can easily find the current. Okay, triple dash. So what is I 2 ohm triple dash? Can you tell me? From here, tell me. Current is voltage divided by resistance. That's it. So tell me what is I2 dash triple dash equal to? Is it 1.875 ampere and the direction is this way? Is this the answer did you get? Yes, no?
Yes, sir, that's what it is.
Okay. So now it's still not over. You'll get remaining marks by writing by superposition theorem. What is I2? I2 dash plus I2 double dash plus I2 triple dash. How much was I2 dash? 5 ampere, right? How much was I2? The double dash minus 2.5 and this is 1.875. So calculate I2 dash, I2 current flowing through 2 ohm will be 4.375. Just cross check this answer. So this is the final answer, 4.375. And this is how you apply superposition theorem. One source at a time. Completed, everyone?
Yes.
Okay. So now we'll solve one last numerical on superposition and then we call it end for the day. And I think that will complete your module number 1. So you all will be in par with your C3 batch now. Okay, whatever syllabus I have covered with them, you all will be in par with them. Fine now.
Yes, sir.
But only thing is there I've given them one assignment, one class test. So it's okay, you can attempt the assignment after that. I know it's a little bit of too much work for you, but we can't help it. We have to start with module number 2 from next lecture, that is from Monday. And you are lagging behind in other class, that's why I have to cover this extra lectures. And I hope this is for your benefit only. I mean, if you still face any problem, I'll share the recording of these lectures so that you can visit that and clear your doubts. Okay, if you
Is
have
there a
any.
Google Classroom of this class?
Sorry.
Is there a Google Classroom or anything of this class?
No, no Google Classroom. We will be sharing, I'll share this in Gmail, the recordings and the
Oh,
handouts.
okay,
Okay.
sir.
I think we have a LMS, so we will be sharing very soon all the things in LMS also. For just for time being, module number 1, all the handouts I'll share via Google link today only. And these lectures also, yesterday's lecture and today's lecture handout. This is whatever I'm writing. Along with it, I'll also share it a recording where I have solved even in LTspice, so you can watch that also. Okay.
Okay, sir.
So we'll solve one last numerical for the day and we call it off. Numerical number 4. So quickly solve it. See, normally these numericals are asked for 10 marks, so you should solve it within 20 minutes. So let's keep a aim of solving it by 115. Yeah, 115. So find current flowing through 10 ohm using superposition theorem. Using superposition, and this is the diagram. 4 ampere. Then we have this 10 ohm, 1 ohm, 10 volt, 2 ohm, and this is 5 ohm. Okay, note down the circuit. We have to find this current I of 10 ohm, I10. Are you ready? Can we start?
Yes, sir.
So for 10 volt voltage source, we'll consider as I1 dash, and for 4 ampere current source, we'll consider the current as I2 double dash. So let's begin. If I'm too fast or slow, let me know. I can slow down or I can speed up. So let's start. First, you consider 10 volt source alone. Okay. So let's consider that and draw the circuit. So 10 volt will be there in the circuit, only one circuit at a time. Then this current source will be open circuited, right? And I have a resistor. Okay. So this is 1 ohm, this is 10 ohm, 2 ohm, and 5 ohm. In this circuit, I need to find I10 dash. Acha, what analysis I will use? Mesh nodal what? Hello, you're there? What analysis I will use over here?
Okay.
Mesh analysis, right? Call this as
Yes.
current 1 and this is current number 2, I2 in loop 2. Now we write the formal procedure KVL to loop 1. What did we get over here? This is plus minus, so this is plus 10 minus I1 minus 10 I1 minus I2 is equal to 0. Remember, huh? Acha, can you tell me what is I10 dash actually equal to? I1 or I2? Or it is I1 minus I2 or I2 minus I1. There are four options.
I2 minus I1.
No, because see, I2 direction is opposite to I10 dash. I1 direction is same as I10 dash, so it will be
I1
I1
minus
minus,
I2.
yeah, I1 minus I2, yeah, correct. So just keep this in mind. For this, you require I1 and I2 both. Okay, so let's solve this. This will be minus 11 I1 plus 10 I2 is equal to minus 10. Let's call it equation number 1. Okay, then we apply KVL to loop 2. Here it is loop 2. So it is minus 10 I2 minus I1 minus 2 I2 minus 5 I2 is equal to 0. That is, this will be 10 I1 minus 17 I2 is equal to 0. We call it equation number 2. Now 1 and 2 we solve it simultaneously. We put it in the matrix form and get the answer of I1 and I2. This is minus 11. This is I1 I2 10 minus 10. Here it will be 10 coefficient of I1 and I2 and 0. So solve this and let me know what is the value of I1 and I2. Anyone? Okay, I'll wait for you. I wait for your answers. Have you all completed?
Yes, sir.
I1
Sir,
is
I1 is 170 by 287.
not 287. No, it's 170 by 87 and 100 by 87. Anyone getting these answers? Or you got 287?
So one second, solving again.
These are the coefficients. These enter in the calculator. Don't make plus minus
Then you
sign.
now got it. 170 by 87. Yeah.
Okay, got it. And I10 dash is I1 minus I2. That will be 170 minus 100 divided by 87. That will be 70 by 87. And that will be 0. How much? 8046. Correct? Yes or no?
Yes, sir. Your point correct.
And the direction is down. Yeah. Everyone else got this answer? Only one person is speaking. Others?
Yes, I got the same answer.
Okay, great. Great. So can we proceed now with the next part? Next part may will consider 4 ampere current source and will deactivate 10 volt voltage source. Is that fine? Let's do it. Consider 4 ampere source alone. So let me draw the circuit. Uh, this is the circuit. This is short circuited, right? This is 1 ohm. This is 10 ohm, 2 ohm, 4 ampere and 5 ohm. Okay. And we need to find current flowing through 10 ohm double dash. How do we solve this? Anyone? Hello. How do we solve this?
So 1 ohm and 10 ohm are in parallel connections. Can we use that
No,
way?
no, we cannot do that. Why you know? Because we need to find current through 10 ohm. If we make it in parallel, that 10 ohm will disappear, no?
Yes, correct.
Acha, do you know nodal analysis? Nodal analysis. Have you studied?
Yes.
So let's do
Yes,
that.
sir.
Let's do that. What is nodal analysis? Let me repeat. I don't know which technique was used to taught you. So you consider these nodes, right? And you consider a reference node. ऐसे ही पढ़ा है ना? Call the voltage as
Yeah.
V1 and V2. Yes or no? यही technique है ना? Let me know.
Yeah. Then we apply KCL at each node.
Correct. So before doing that, you define the currents. So this is the outgoing current. Always represent outgoing current. Let's call it I1. This is I10 double dash. Let it be I10 double dash. This is I2. Your current is already defined. Here you define outgoing current as I3. And now you apply KCL at each node, right? Correct now?
Correct.
KCL at node number 1. So what is KCL? Incoming current is equal to outgoing current, right? Now at node number 1, all the currents are outgoing. Agree? Yes or no? So we can write I1 plus I2 plus I10 double dash is equal to 0. Correct? Yes or no, Babak? Tell me.
Yes, yes.
So what is I1 now? V1 minus 0 upon 1, right? What is I2? V1 minus V2 upon 2. What is I10 dash? V1 minus 0 upon 10. So V1 upon 10. Did you all understood this?
Yes.
Same technique only na, but my method is, not my method, its simplified method is this. You don't solve it further, you keep it in fractional form only. So you write it V1 plus, don't solve this, don't write V1 by 2, write it as 0.5. V1 minus 0.5 V2, 1 by 10 is 0.1 V1. Write it in this form. So you club all the terms of V1 together, what do we get? Uh, what do we get over here?
1.6 V1,
1.6 V1 minus 0.5
0.5 V2.
V2 is equal to 0. Call this equation number 1. Okay. Now we apply. So have you completed up till here? I'll wait. Was this the technique followed? Actually, this is the only technique which you can follow. Other is conductance method also. But this is all the same thing. Safest one.
This only was thought.
Okay, great. So next is KCL at node 2. So tell me, at node 2, which is outgoing current and which is incoming current?
So incoming is 4 ampere.
And to I2. 4 ampere and I2, right?
Yes, yes, correct.
And I3 is outgoing. So we'll write I2 plus 4 is equal to I3. And what is I2? V1 minus V2 upon 2 plus 4. What is I3? V2 minus 0 upon 5. That is V2 upon 5. Got it? You all agree with this?
Yes, sir.
Then you write fractional form, zero point 0.5 V1 minus zero point 0.5 V2 plus 4 is equal to, this will be 0.2 V2. So solve this, you will get 0.5 V1 minus 0.7 V2 is equal to minus 4. So you need to calculate V1 and V2. And how do you do that? You better know it using fractional, using this matrix. So your coefficient of V1 will come, coefficient of V2 will come, and on the other side whatever is there, 0 is there, so 0 will come. Here it is 0.5 minus 0.7 minus 4. So let me know the value of V1 and V2. You're almost 2-3 minutes away from solving this. Yeah,
Yes, sir.
V1,
200 by 87.
yes, that's correct. And
V2 is
V2,
640 by 87.
perfect, 640. Okay, let me write 6. Acha, ye V1 and V2 we got. What is I10 double dash? Arey, what is I10 double dash? Anyone knows?
So you can substitute V1, V2 in that equation, I1 plus I2
No, no,
by
no,
10.
no. Wait. I10 double dash is V1 upon 10. ये देखो ना इधर किया ना हम लोग ने. Correct ना? I10 double dash is V1 minus 0 upon 10. So why are simply it is very simple. So I10 double dash is, let me write this properly, is how much? V1 upon 10 ohm. Current is voltage divided by resistance, na? V1. And what is V1? 200 by 87 divided by 10. So just calculate this. 10, this will cancel out. 1 0 will cancel out from here. Tell me the answer. It's 20 by 87. Tell me what is I10 double dash. 0 point something will come.
0.229.
0.229, after that 8
8, yes.
ampere. That's it, and that is also down. Now what do we say? By superposition theorem, by superposition theorem, I10 ohm is I10 dash plus I10 double dash. So I of 10 ohm is, how much was I10 dash? 0.8046 plus 0.2298. So how much is this? 1.0348. Did you all got this answer?
Yes, sir.
Yeah. So yeah, we told that we started at around 12:53 and we took 17 minutes to solve this. So yeah, well within 20 minutes. So you should also keep a target of solving every numerical within 20 minutes, and that too correctly. So superposition theorem is very simple, but it takes a little more time. Okay. So today we have discussed superposition theorem and maximum power transfer theorem. Now before we leave for the day, that's it for today. Do you all have any doubts? You can ask right now.